Hello everybody, welcome to another episode of Coding the Cult. Today is a great day to learn how to code, and today what we're going to be doing is we're going to be building and expanding upon what we learned the last time with the Arduino. So last time we learned a little bit about Ohm's Law, what current, voltage, and resistance was, and we learned how to light up and flash an external LED. So today we're going to be taking a look at using a RGB or red, green, blue LED with our Arduino. So our learning goals today, we're going to learn what an RGB LED is. We're going to learn the difference between digitalWrite, which is what we used last time to light up our LED, and analogWrite, which is what we're going to use today. We're going to learn how to generate a random number on an Arduino, and we're going to learn how to write a function on the Arduino that we can call over and over again. So let's start out. Let's take a look at the schematic and then take a look at a drawing of what we're going to hook up. Then we're going to go over to the workbench. We're going to take a look at the parts we need. We're going to build the circuit. And then we're going to come back and we're going to program that circuit. So this right here is the schematic diagram. So this square or rectangle, it's a rectangle, represents our Arduino. And it's got all the pins on the Arduino. Now they're not in the same order, but each one of these represents the pins on the Arduino. So what we're going to need is we're going to need three resistors, three 220 ohm resistors, and we'll go over what colors those are in just a second. We're going to need an RGB LED. We're going to take a look at what one looks like in just a minute. And we're going to need at least 4 jumper wires. I recommend you get a red, a green, and a blue because they're going to correspond to our LED colors, and then a black for the ground. So essentially what we're going to do is each leg, there is a red, a green, and a blue leg on the LED. The red leg is going to go through a 220 ohm resistor and hook up to pin number 11. And you'll notice pin number 11 says PWM on it, pulse width modulation. And that's important. This won't work on just any of the pins on the Arduino. The pins have to be able to supply what's called a PWM or pulse width modulation signal. You see, on the last project, when we hooked up our LED, we could only turn our pin on or off. It was either supplying a full 5 volts or it was supplying no voltage whatsoever, no in between. So our LED was either all the way on or all the way off. Well, for the RGB LED, it works a little bit different. We have to supply a range of signals, anywhere between 0 volts and 5 volts. And that's going to determine the amount of each one of those colors. So for example, if we told it, hey, turn on pin number 11 at full red, and don't turn on pin blue or green, which are going to be hooked up to pins number 10 and 9 and 10, then our RGB LED is going to look red. If we said, hey, only do partial red, but a whole lot of blue, that would be a very, very bluish purple color, if I'm not mistaken, if I know my colors. So essentially what we can do is we can control the brightness of each one of these LEDs, the red, the green, and the blue. And that brightness is going to, for each one of these red, green, and blue, is going to determine the overall color of the RGB. So essentially what we're going to do is each leg of the color legs, the red, the green, and the blue, are going to go through a 220 ohm resistor. That's a current limiting resistor, if you remember from the last lesson. That protects the LED so it doesn't burn out, so it doesn't get too much current flowing through it. So this limits the current. And we're going to hook each one of those up to pins 9, 10, 11. And then there is a pin, what's called a common cathode, meaning that all the pins are hooked up to that cathode or that negative pin. And that's going to hook up to a ground pin on the Arduino. Let's take a look at what it looks like in the drawing. Then we're going to go over to the workbench and we're going to take a look at the parts. We're going to actually build the circuit. Okay, so this is what it looks like. This is our Arduino. Now, I put these parts aside just to show you what they look like. Our 220 ohm resistors. If you have a 5-band resistor, which if you have the analogWrite kit, which I'm using, and I highly recommend, it's a great kit at $40. It comes with a ton of stuff. But the color bands are going to be red, red, black, black. And then this 5th band doesn't matter. I think in the analogWrite kit it's brown for 1% resistor. If you've got a 4-band color code, they're going to be kind of a tan or beige colored resistor. Your color codes are going to be red, red, brown. And this 4th band, once again, doesn't matter. Then you're going to have a RGB LED. Now on yours, as we'll see in just a minute when we look at the parts, one of the legs is going to be longer. And in fact, if we turn it, it's going to be this leg right here, the second leg from the left. That's going to be the cathode, or the negative terminal on the LED. So I'm going to place my LED. Notice how I've got it placed. There's a break in our breadboard. I've got it placed on the other side of that break. So this pin right here is the longer pin. And I'm going to connect a black wire from it straight over here to ground. Now then, on each one of these color legs, the red, that's this one, the green, and the blue, I'm going to hook up a 220 ohm resistor. And notice it bridges that gap in the middle. We'll look at that in just a minute. So it bridges that gap. And then I just chose the colors of wires, red, green, and blue. So red's going to go to 11, green to 10, and then blue to 9. Another thing I want you to notice on your Arduino, see that little tilde? What that means is that those pins are capable of supplying a PWM signal, a pulse width modulated signal, or in other words, it's capable of supplying, instead of just being off and on, it can actually supply a range of voltage from 0 to 5 volts. So the circuit's pretty easy to build. Let's head over to the workbench and let's take a look at the parts we need, and let's get it built. Okay, so here we are on the workbench, and I've got all the parts laid out. You're going to need your breadboard. You are going to need your Arduino, and notice how I have mine oriented. I have it so the USB is facing here to the left, and that's probably what you're going to want to do. You're going to need 4 jumper wires. I recommend that you have a red, a green, a blue, of the shorter variety. If you have the analogWrite kit, there are long ones and short ones. Go with the shorter ones. And then a black for the ground. You're going to need 3 220 ohm resistors. And once again, the color on those resistors is red, red, black, black. Let's see if my camera can focus. It's very difficult to see the color bands, I think, but it's red, red, black, black. And then brown for the tolerance. Last thing you will need is a RGB LED. You have 2 in the analogWrite kit. And one thing I want to bring to your attention, see if we can focus on this. One leg is longer than the other 3 legs, and it's this one right here. That's the common cathode. That's the negative terminal on the battery. And the one just to the left of that is your red, then your green, and then your blue. In order to get this into the breadboard, you might have to separate those out a little bit. In fact, let's go ahead and start building the circuit. Doesn't matter where I put this. I'm going to stick it so that each terminal goes into its own spot or column on the breadboard. All right. There, I think I got it. There we go. So I think you can see each one is in its own row or column on the breadboard, with once again that second one is a common cathode. Okay, so now I am going to find one of the ground pins on my Arduino. I'm going to stick the black cable into there, and then I'm going to run it so that it is in the exact same column as that common cathode. So there we go. Let me zoom in a little bit. All right. Next, what I'm going to do is I'm going to take my three 220 ohm resistors. I'm going to bend them just a little bit, and I'm going to put one on that red leg of the RGB LED in the exact same column that it's in. And I'm going to bridge the gap, and let's see if I can get it. We'll have to say one of the things about the breadboard on Elegoo Kit is it's not a very good breadboard. I think that's got it. All right, let's see if you can see this. All right, yeah, I think you can see that. So that LED is in the exact same column as the red. And then it bridges that gap and goes in right there. Then what I'm going to do, so I'm going to take my red wire. It's going to go in the same column. And then it's going to connect to pin number 11 on the Arduino. Now what I'm going to do is I'm going to do exactly the same thing with pin number 10 and pin number 9. Pin number 10 is green. So I'm going to get another one of my resistors. And I am going to put one end on the green pin. Now notice, it's the third pin from the left because it goes red, common cathode, then our green pin. So I'm going to put one end in there. I'm going to bridge the gap, stick it in on the other side, and then my green goes in number 10. And then in the exact same column, oh, I've broken, oh no, I've broken my green wire. All right, let's see here. Grab another wire. Okay. So this is going to go, once again, in pin 10 on the Arduino. And then I'm going to stick it in the same column I did there. All right, let's see once again if you can see this. So you can see that one end of that LED is in the exact same column as the third pin. That's the green pin. I bridge the gap. I stick that in a empty column there, and then the green wire goes in the exact same column and then goes to pin 10. The blue wire is going to go in pin number 9. Now I'm going to do exactly the same thing over here. I'm going to put that other 220 ohm resistor. And by the way, you can use a resistor larger than 220. It's just your LED won't be as bright. So you could use like a 1K or 1000 ohm resistor. You can actually go a little bit smaller. I think you can go down to about a 100 ohm resistor. Okay, so once again, the very last pin is the blue pin. I'm going to put one end of my resistor into the same column as that pin, that blue pin. I'm going to bridge that gap and put it in an empty column on the other side, and then take my blue pin, the other end of my blue pin, and put it in that exact same column over here. There we go. All right, so in the end, it should look a bit like this. Let me move that out of the way a little bit. All right, so once again, that blue pin, one end of the resistor, goes in the same column as the very last pin, the far right lead on the RGB LED. And then I put the other end in an empty column. Notice I skipped a column, but not a big deal. On the empty column, but then the blue pin goes in that exact same column and then plugs into number 9. Okay, let's head back over to the computer. Let's get this all hooked up, and we will start programming. So see you back over at the computer. All right. So we're now going to write some code to control our RGB LED. Unlike the last couple of videos, I'm not going to type it out live. I think it's going to save some time for me to have at least part of it done. And I'll just explain it to you as we go along. So up here at the very top, I'm going to set up 3 variables. They're going to be integer variables. That's what this is, int. In Arduino sketches, we have to do what's called declare our variables first, and we have to give them a type. So basically what we're saying is, let's have a variable named red pen. Red underscore pen. I couldn't name it red space pen because variables can't have a space in them. So it's fairly common to separate words with an underscore. So what I'm doing is I'm saying, hey, I'm going to have this variable. It's going to be named red pen. I could have named it anything I wanted to, but it just kind of makes sense to call it red pen because it's going to control the amount of red or the red pen on our LED. And we're going to set that equal to 11. So it's kind of like I made a little box inside of the Arduino's memory and I called it red pen and I put the number 11 in that box. I do the same thing with green pen and blue pen. I make 2 variables, both of them integers, and integer just means it can hold a number. It couldn't hold a letter, couldn't hold a floating point number. It has to be a whole number. It could be negative, like -10, but it couldn't be 3.14159 or 10.9 because those would be floating point numbers. Another thing to notice, each line ends in a semicolon. That's important. Without that semicolon, it's not going to work. Then I of course, have the void set up and the loop function. So when you go file new, those are created for you automatically. So like here's a new file for me and those are created automatically. And remember the setup is where we do our various setup stuff. And we are going to set up in between, that's another thing, make sure this code appears in between the curly braces, okay? So what the pen mode function does, pen mode sets a pen to input or output. There's a few other things, but don't worry about that. It takes the pen number, in this case we're going to give it the variable, which holds the number 11. And we're going to set it to be an output. That means pin number 11 is going to be an output. We can produce voltage on that pin. And we're going to do that with the green pin and the blue pin. Notice once again, these lines end in semicolons. This white space that I put here doesn't matter. I just did it to make it a little bit easier to read for a second. Then remember what our loop does is it literally does that. It loops over and over and over and over and over and over again. So basically it's going to do this line, then this line, then this line. And when it gets to here, this curly brace that ends the loop, it's going to go all the way back up to the beginning of the loop and do this line and this line and this line, etc. And just keep doing that forever until we turn it off or whatever. All we do in loop is we're going to call the function called analogWrite. Now, if you remember in the last video, we used a function called digitalWrite. And digitalWrite took a pin number just like this, but we could only set it to high or low. It could only either produce 5 volts or have a 5 volt potential difference or 0. Well, analogWrite is a little bit different. We give it a number between 0 and 255. 0 means don't produce any voltage on that pin. And 255 means produce 5 volts. A 5 volt signal. Light up that LED as bright as it can go. If we did 128, it would go in between. So 128, that's the middle. It would produce about 2.5 volts. And so what that does is it varies the brightness of our LED. Now in this case, all we're doing is we're saying light up the red pin as bright as it will go, but not the green pin and not the blue pin. So our LED should be red. So what we'll do is we'll just click upload, and if we haven't made any mistakes, should upload, and it has. And our LED should be red. And I wish I had a camera that was focused in on this, but there we go, it's red. Now if yours isn't lighting up, check your circuit. Make sure you have good connections and everything's connected properly. Now then, I could, let's try value of 50 here for red. So what should happen, you don't know if you can see it, it's not quite as bright, not nearly as bright. So let's give this a try. Let's go 255 on red again. Let's copy this, and I'm going to paste it. And right here, I'm going to put delay 1000. And if you remember what delay does, it literally does that. It just delays for that many milliseconds, which means here in this case it's going to be a second. And let's turn off our red and put full voltage to green. And then, whoops, that's not what I meant to do. I'm going to copy this. Remember, programmers are lazy. So if we can copy and paste, we will. And I'm going to turn off the green pin and then turn on the blue pin at full value. So what we should have happen is it's going to turn on the red pin, delay for a second, turn on the green pin, delay for a second, turn on the blue pin, delay for a second, and then do that over and over and over again. So all right, let's see. There's the red, the green, the blue. The red, the green, the blue. So it works. Now comes the fun part. We can combine these into different colors. So let's do full red and full blue. Whoops. See what we get. Yes, we get that very kind of purple color. Let's do full red. Let's do full green and full blue. Oh, just had a light fall. There we go. Kind of that really kind of aqua blue there. Turquoise. I don't know what you call that. Not an expert at colors. And then if we did full red, green, blue, we should get pure white. That's pretty close. Looks a little bluish to me. Okay. Well, and then once again, we can experiment. Let me put in full red, and then maybe half green, and not half, about 64 green and half blue. Let's see what we get. That's kind of neat. All right. So that's fine. That's neat. But let's write ourselves a function. And let's see here. What it's going to do, we're going to call a function. Well, let me just write it, and then I'll explain it to you. All right, I can copy and paste this. Okay, so what I've done is I've wrote a function called RGB color. And all a function is, it's a block or a group of code that we group together under a name. So in this case, it's called RGB color. And I'm going to pass to it, too used to programming in Python right now. We're going to pass to it, or give to it, 3 values that we can then use inside of the function. We're going to pass to it a red value, a green value, and a blue value. Once again, these are just variables, parameters. I could have called them anything I wanted. Could have called this one Luke Skywalker, this one Princess Leia, and this one, I don't know, Chewbacca. But since they're going to hold the red, the green, and the blue value, then I think I should call them red, green, and blue. So the way a function works, or the general structure of a function, I've got void. Don't worry about what that means right now. I know it's a little bit confusing for right now. Just know that this word void needs to be there. That can actually be different depending upon what we want to do, but for right now, let's just put void there. Then the name of the function. So I'm going to call mine RGB color because it's going to turn on our RGB. Then inside parentheses, if I want to pass any information to that function, I put it inside of these parentheses. And what it's doing is it's saying, hey, I'm going to give it an integer value that you're going to put inside of this variable called red, and an integer variable that we're going to call green, and an integer variable called blue. I must tell it the type and the name. Then down here I can refer to those. So red will have whatever value that we pass to it, and so will green, and so will blue. And so what I'm going to do in my RGB color function is I'm just going to turn on the three LEDs, red, green, and blue, the red pin, the green pin, and the blue pin. And I'm going to turn it on, or pass to them the red, green, and the blue value that we pass to it. So I used it right up here. I said RGB color, and the first time I use it, red's going to be equal to 255, so it's going to use 255 here. And then green's going to be equal to 0, and blue's going to be equal to 0. And then I could also use it more than once. I could say delay, just like I did before. And lastly, okay. Oh, and I got a delay. Okay. Well, let's do this and see if it works. Oh, I got an error. Oh, I forgot my semicolon. A couple things about it, errors. It literally told me it expected a semicolon before RGB color. So when I look right here, it highlights the error RGB color. It's saying I should have had a semicolon before it. So that means on the next line, I should have had a semicolon. Of course, you know, I totally did that error on purpose just to demonstrate that, right? Okay. Oh my gosh. I forget it again. Oh, I did. So I've been doing a lot of programming in Python lately, and you don't need the semicolon in Python. There, it worked. All right, let's see here. Red, green, blue. Red, green, blue. Red, green, blue. Okay. So we know it works. So now what we're going to do, I'm going to get rid of all of this. Okay. What would be really neat is if we had it just randomly cycle constantly through random colors. And we can do that. There's a function on the Arduino called random that'll give us a random number. And so what I'm going to do is I'm going to call it 3 times. I'm going to make 3 variables, a red, a green, and a blue. I'm going to say R. Oh. Yeah, let's do this. I'm going to show you 2 different ways to do this. One way is a little bit easier for you to understand, probably. I'm going to make 3 integer variables. A red, a green, and a blue. Up near the top, I'm just going to call them RGB. Okay. So I made 3 variables that can hold integers. One's called R, one's called G, and one's called B. And I'm going to set, in my loop, I'm going to set R equal to random 255, green equal to random 255, and blue equal to random 255. So what the random function does is it does exactly what it says. It's going to generate a random number from 0 to 255, and then it's going to assign it or put it in our variable called R. And the same thing with G and same thing with B. And so now instead here I can go R, comma G, comma B. So now each time through a loop, we're going to get 3 different red, green, and blue values, and we're going to delay a really short time, and so it's going to flash through a whole bunch of random colors. All right, here we go. Yeah, there we go. It's working. What would be neater is if we maybe varied the amount that it delayed. So watch this. You can actually call a function from inside of another function call. So what I could do, instead of putting a number here, I could say random, and random can actually take two values. The first value is the starting value, let's say 50, and the next value is the ending value, let's say 500. We got to be careful with our number of parentheses here. That's an open parentheses and a close parentheses at the end, and an open and a close. So we're going to delay for a random time between 50 milliseconds. Heck, let's make it even shorter. Let's make it 10 milliseconds to 500 milliseconds. So it's going to flash random colors and delay a random amount of time. All right. Now, I told you I was going to show you a couple different ways to generate these random colors. So what I did here in my loop was I generated a variable called R, G, and B. I generated a random number and put them in there. And then here I called it with our RGB color function with our R, our G, and a B. Which now hold a random value from 0 to 255. R holds a random value from 0 to 255. G holds a random value from 0 to 255, and so does B. And then when it calls RGB color, it puts those random values here, here, and here, which then our function can refer to them here, here, and here. Well, I actually like to do it this way better. I think this is very readable, and it's pretty obvious what's happening. But you could, if you wanted to, do it this way. I just didn't do it this way to start because it can be a little confusing when you're trying to read the code. Okay, so now RGB color is going to pass to our function call. It's going to pass a random R or random red, a random green, and a random blue. I don't think this is as easy or as easy to read, but that's just me. It takes a second to figure out what's going on here, whereas the other way I thought it was much easier to read, but it ends up being exactly the same. I just downloaded it and you can see it's exactly the same. Okay. So that's it. I think we covered everything we wanted to cover. Experiment with this. The best way to learn to code is take some code, begin experimenting with it, changing it, seeing what happens if you do, this or that. See if you can hook up a second RGB LED into the circuit. It's going to be exactly like the first one. Okay, you can put it, right beside the other one. Be careful which pins you use. Remember, they got to have that tilde on it because not all pins can generate a range of voltage or a PWM signal. It looks like you can use pins 3, 5, and 6, which are on that same side as pins 9, 10, and 11. But anyways, experiment. If you've got any questions, put them down in the chat or put them down in the comments. I'll try to answer them if I can. Once again, I'd really appreciate it. If this is your first time here, go ahead and subscribe to the channel and like the video. Until that time, today was a great day to learn a little bit about coding, and I'll see you next time. Bye-bye.